I'm fine, Dev. How are you?
I'm fine too. We are meeting after almost 2 weeks. So,
Yes.
what's your topic today?
So basically, I will be sharing on the topic of the producer and consumer problem in operating system.
Sounds interesting. Yeah, you can start.
Yeah. So first of all, let me just share my screen, right?
Yeah,
So let me know if my screen is visible.
yeah, it is visible.
So can you see the full screen of PPT first slide, the
Yes,
producer and
yes.
consumer problem? So uh, let me start with the pointer in my hand. Just a second. Yeah. So you can see the topic of today's discussion is the producer consumer problem, and which is related with the term inter-process communication. Right. Whenever we have heard the term inter-process communication, then this problem might you have heard. This problem was actually covered by a very famous scientist. The name is Dijkstra. I think I don't know full name, but the scientist name is Dijkstra. We will
Mhm.
also discuss on this scientist and what are the inventions in the upcoming session of this producer consumer problem. So today what we are going to see. So producer consumer problem is very famous problem, but today we are going to see that what is IPC critical section, what is the real scale example and the complexity of this same problem, and the basic solution of this producer consumer problem, and what is the problem in the solution. Like for this problem, we have different level of solutions, like level one solution, level zero solution, and we are going to see that what are the problems that encourages us to give the solution of from level zero to level one, and from level one to level two, and how we are able to solve. Like level zero, there are some problems, and level two, one, there are minimal problems. So we are going to see that. So what is inter-process communication? So basically, there are two types of processes. As you might know, that there are independent process that do
Yes.
not have the direct connections. They are executing independently in the OS, and there is a very good that is very good scenario, that there is no collision and there is no something that we have to deal with. And if we talk about the cooperative ones, then there might some problems like uh, they might collide with each other, or they might have access to same memory section, so they can have some data loss. So this cooperative one's process is basically falls under the inter-process communication. How we handle the inter-process communication, that's the whole different topic. But for us, let us consider that there is one critical region. So, what is critical region first of all? So, to understand the producer-consumer problem, we must aware about this one term which is called as critical region. So, basically, if we talk about the inter-process communication, so why it is important nowadays? So, you might have heard that information sharing, and we also know what is modularity. If we are dealing with some programming, then we have some modules like for printing module, for taking input, and there are for different tasks we have different kind of modules. So, and also to increase the computational power. So for this purpose is the inter-process communication is very important. And a situation where several process access and modifies the same data is called critical section problem. And this situation is occurring on which same data, and the same data is referred as sometimes critical region. On the right hand side, if you might see this diagram, that this is some section this is some memory portion, and these are some addresses like 4 address, 5 address, 6 address, and there are some textual data. And this what you can ignore spooler directory for now. You can just imagine that this is some kind of memory and these are addresses. There are two shared variables between this process
Mhm.
A and process B. That this is in and this is out variable. So what are these variables for? So first of all, this in variable indicates that where in this puller directory, or you can say in this memory, where we can put the next data. And if we talk about this out variable, then it is then what it indicates? It indicates that from where we need to pop out the next item if we want to read something. So now if we talk about this puller directory, so which is basically which is nothing but if you want to print something right on the screen. So printing takes time. So this puller directory maintains the queue that which are the text or which are some files that we want to print on the screen. And
Yes.
you can consider this process B and process A. Like uh, they want to access this puller directory and let this puller directory know that this item to be print first. Suppose process A want to print something, so it can access this in variable, and it can you can say it can add the item that it needs to be printed. And suppose if process B want to output something, then it can access this out variable and it can have access to this fourth number of data and it can print something, right? So this is how whole system works. Now, suppose these are currently shared variables, but how to manage this shared variable? That is all about the inter-process communication. So, in real scenario, if we talk about the race condition and all that thing, so how the ideal scenario would look like? Suppose the process A is accessing in variable. So, and at the same time, process B is requesting for this out variable, then there is no collision. But at the same time, process A and process B want to know the directory, puller directory that we have some item and we want to print something. So they will be accessing the same variable, this in variable. And suppose this is process A that it is currently acquiring this lock, or you can say currently accessing this variable in. And at time t2, you can see the time barrier over here that at time t2, B wants to print something, and for that
Yes.
it yes for that it also needs to access to this in variable. So actually this cannot happen because the process is currently accessing the in variable. So actually in real scenario the process B has to wait, and after you can see the process A ends over here, then process B can have access to that variable. So this is how actual real case scenario would look like. So I have in this slide I have given you overview of the what is producer consumer problem.
Now we have, as we have discussed on the overview of a critical region. Now let us look at the actual complexity of the and the real scenario for the producer consumer problem by taking example of farmer and customer. So suppose there is one farmer which will act as a producer, which will produce different items like grains and fruit, etc. And suppose there is one customer who will consume the item which are produced by the producer. In this case, by the farmer, right? And suppose this is a warehouse where a producer, you can say
Yes.
farmer will store some items which are produced by the farmer, right? And suppose these are some different items that are produced by the producer, like this is strawberry fruit and this is grain wheat, right? So how farmer will produce the item? After producing the item, it will do, it will store in the warehouse, and from the warehouse the customer will access whatever the items he will or you can say whatever the item he wants to consume, that will be accessed within this by this warehouse. So what farmer will do? Farmer will produce the item and put it into this warehouse. And after some items are there in the warehouse, the customer will go to warehouse and purchase some items that he wants to consume. So what you can consider that this is individual process. The farmer is not accessing or not talking with the customer. He will just produce the item, take its own time and store it into the warehouse. And after there are some items, what customer will do? Customer will check after some times that frequently check that warehouse is there is something item in the warehouse. And if there are some items in the warehouse, then customer will access those items and consume that whatever he wants to consume. Right. So you can consider that different items can be produced. Like you can see the grains and the strawberries. And you can see each item can have different production rate. So this is now getting very complex. Like you can see the grains, production time of the grains and production time of these strawberries, fruits are different from each other. And each item can have different consumption rate. Like production rate from the farmer side will be different for these two items. And similarly, the consumption rate for these two items are different from the consumer, or you can say customer's rate. So this is somewhat we have added complexity. And if we want to add more complexity, then you can consider that each producer can have different production rate for the same item. So what up till now, what we have seen that there is one producer and there is one customer. But you can expand this scenario by taking several producer and several customer. So for each of the producer, for different, you consider that there are different farmer. One farmer is having good production rate for this fruit because he is only you can say he is only producing the strawberries, and one farmer which is producing these both two items. So we can consider that the production rate for the farmer of the which is producing these two items will be low, and for the farmer who is producing only strawberry, for that the production rate would be higher. So for distinct item there can be different production rate depending on the producer. And similarly, each consumer can have different consumption rate for the same item. So someone likes to eat strawberries much. So what he can do, he can consume the strawberries faster. Then the customer would like to eat both. Like he like to eat strawberries as well as wheat. So you can see that each consumer can have different consumption rate for the same item. So this is somewhat more complex than the scenario which we are looking forward. And how to manage such things, that is the producer consumer problem. So you can have the idea that how much complex the problem is. Now let us discuss the code for the same, that how we can look at the producer consumer problem in terms of code. So consider that this is a count variable, which is indicating that how many items are there in the warehouse. A warehouse that in terms of the buffer that we have talked previously. So producer, this is a function of for producer, that what the function of producer, that what producer will do. So this is item that will be produced by the producer. And while you can see this is infinite loop, while true, meaning that producer will produce until and unless these conditions are satisfied. So this is you can see infinite loop, and these actions are repeatedly performed by the producer. So what it will do, it will first of all produce the item. You can see this function produce item and item P. And you can see this is all again any one infinite loop, that while count is double equals to n. So this falls under basically the bounded buffer problem. There are two kinds of producer consumer problem that are proposed by the Dijkstra scientist, that is very famous, and that we will see in later on videos. So for now, you can consider that the warehouse that we have seen in the previous example, that is having some limits. that up to this much item we can store. So this is that condition is checking out over here, that while the count is double equals to n, meaning when the buffer is full, so producer cannot produce any item. So actually the producer can produce item, but it cannot store into the buffer. You can see buffer in that we have in variable that we have seen in the previous example. So buffer in is equal to item p. This action, what this action performs? This action performs the storing of item p into the buffer, or you can say into the warehouse. But it cannot store into buffer until the size of the buffer is full. So this is that condition checking out over here. And after it is stored into the item, this is for you can consider in variable that the size of the buffer is we have taken is 8. So what it will do, it will basically point to next empty cell in the memory. So after producing one item, we cannot produce in the same you can say same address of the memory. So that's why we have incremented the in variable like here you can see in plus 1 modulo 8.
Yes.
And we have increment the count over here. And same way for the consumer, the count is 0. Actually, this line should not be over here because this is shared variable. So we don't have to declare 2 times. And this is item that will be consumed by. So what are the tasks that will repeatedly followed by the consumer? That first of all, it will check the you can say the warehouse is not empty. So until and unless the warehouse is empty, it will go for the infinite loop. That is condition similarly like we have seen over here. And after there are some items in the warehouse, the consumer can consume the item. You can see this is consumed by the consumer and the count variable is decremented. And after it will take some time to process the item. So for that, this function is called. Now, the critical section that we need to look out is over here. You can see this count variable. The actually in producer code, this count incremented happening is very critical. And in consumer, similarly, this decrement of count is very critical because
Yes.
you can see this is you can see this is the micro operation that are performed by the CPU whenever we are incrementing the count variable and decrementing the count variable. So first of all, what it will do, load the this is consider this is a register. So it will load the count variable into register, then increment it and then again store it. And similarly over here, it will load the count variable, then it will decrement and then it will store. So if we this is the basic solution, and there is one problem associated with it. So for you can consider that the preemption will happen whenever some producer in there is in CPU and whenever the consumer in there is in the CPU. So suppose producer is in the CPU and executing this load these 3 operations. And from this second operation, the preemption is happen and this consumer process of the consumer is preempted into the CPU. So if we follow this kind of context switch and the order of the execution, then it will lead to a data loss of this count variable. So first consider that there are 4 items in the let me just take a pen. So first of all, consider that there is a 4 items in the buffer in the warehouse, and after one item is produced by the producer, then what variable should be there? Like 5, right? 4 items were there, and one item is produced by the consumer. And suppose these you can say these 3 instructions are executing. So first of all, count variable will be loaded. The 4 will be loaded into R. So 4 will be loaded into R and then it will be incremented. So incrementation operation is done. So it will increment it to 5. And now the context switch is happen and the consumer is preempted into the CPU. And what is the variable of count? So the count is 4, right? Because it is updated, but it is in the register. It is not stored yet. by the producer. So what will happen? So first of all, it will be loaded. So suppose this register now cannot be used. Suppose there is one register R0 and the variable is 4, right? So what happened now? So first of all, 4 will be loaded and decrement operation will be done. So it will be decremented to 3. And now again the context switch is happened and you can see the PI3 is getting executed. So actually this 5 variable that was stored in the register that will be updated now. So now the value of the account is 5. But now again context switch will happen and CI3 will get executed. So now the 3 will be updated as the count variable over here. So actually there were 4 items, right? And one item will be produced and one item has been consumed. So actually there must be 4 items right now into the buffer. But accidentally by this order of the execution, the items that we are getting now, count of the item is 3. So one item is there, but we cannot consume because of this type of error or this type of order of execution. And if we look out for the name of this situation, so this is considered under the race condition problem of the race condition. This is very famous if we talk about the operating system. So what is the solution of this producer and consumer? So this is solution, this sleep and all these things, but we are not going to see details right now. We will discuss in later on videos. And this is the scientist that I am talking about. This is a Dijkstra. This is the scientist's name is Dijkstra, but I don't know the full name. So thank you for this session. And before I will conclude this session, let us just look at the code, actual code. So I will quickly. So you can see this variable or you can see this screen. So this is I have written the code of basic producer. This is the list of you can see this is buffer and this is end of file for ending of the process. So this is basically the class for basic producer, and for implementing the thread, I have implemented the runnable. And this is actually the constructor for this producer. And this is the run method. So what it will do, it will produce 3 items. You can see 1, 2, 3. And after production, it will add it will print the message that I have added. And after ending up these 3 items, it will say that I am ending up this production process and I am leaving this, you can see, leaving this CPU. And it will simply add the end of file. And if we talk about the consumer, then it will first of all check that the buffer is empty. If the buffer is empty, then it won't do anything. And if the buffer is not empty, then it will read the first item. If the first item is end of file, then it will simply exit. And if it is not, then it will say that I have consumed the item and it will consume. And the rest other things for the consumer is also same. Now, if we talk about the main function, then you can see I have simply implemented the buffer over here. And this is the thread, and thread is for basic producer. And I have passed the same buffer. And these are 2 threads for consumer. You can see. And I have also passed the same buffer and end of file over here. And these 3 threads are starting one by one. First of all, producer, then consumer, and then consumer. This code will lead to error. So that I am saying from my side, it will not always lead to error, but we will see. So you can see consumer 1 removed 1, removed consumer thread 1, removed 1. Producer, you can see the order is very much like you can see uneven. before producer has produced the item, consumer is consuming the item number 1.
Yes.
And you can see producer has produced 2, 3, and consumer removed, and producer is now leaving. And consumer 1 is exited, but consumer 2 is still waiting, and you can see program is still running. So if I just end the program like from this button stop main, and if I run again, then it will lead to again another output. Let's just see. So you can see in this case, the program has been successfully executed, but the order, like say, like that I have said before, the producer is producing, but the consumer is removing before the producer is produced. Now, if I run again, so you can see the producer has lived the production, but the consumer are still waiting. So this type of problem we can see whenever this doesn't matter. Whenever every time if we run this program, it will lead to different kinds of output.
Yes.
So that's the problem. Thank you for listening.
Yeah, good one, Anil.
Thank you, Mr. Dave.
Okay, then see you next week.
Yes.
Bye.